Okay, so this is Dr. Mitchell again, and we're going to walk through doing both correlation and regression with JASP software. And so I have a data set here, and I'm going to start in Excel just to kind of show you how both of these look. And although we can do both correlations and regressions in Excel, doing them in JASP does give us a little more information, a little more detailed analysis than we'll get with Excel. So here I just have a basic data set. I have two variables, A and B, and each of these have values, and then each row is going to be a subject here. So what I've already done, I've actually already made a graph chart here with A and B on their respective axes. And as you can see, doing this scatter plot, you can tell pretty easily there's some relationship here between these data. It's an inverse relationship. And as we've done before, we can do correlations here, and I won't go through that because we've done that. We can do, in our chart, we can come up with a regression line. So if you recall, we can go to our chart area, design, add a chart element, add a linear trend line, and we can not only do that, we can, if we format our trend line, and I'm going to move that picture over there, we can actually get the equation, this regression equation, for us. And let me make this a little bit bigger so we can see it. And so there's our regression equation. And this is really helpful as far as doing both correlation and regression. We can also do this in JASP, and I would argue it's a little bit easier. So I'm going to go to our JASP software, and I'm going to File, I'm going to Open, and I'm going to go on my computer, go to my desktop, and we're going to get, where are we here, our data that we just had. And so, because I had formatted that Excel document in a CSV file, I could now open this fairly easily in JASP. So I now have this open. I'm going to start with correlation because both correlation and regression are obviously related. And we're going to do a classical correlation. So I'm going to click on that. And immediately a new window opens here. And so what it wants to know is, hey, what are your variables? What do you want to correlate? So we're just going to put A over here, B over here. Now, one thing you're going to notice is in each of these areas, there's a little value here. And actually, both of these little icons tell you what kind of data this is. Now, these should have little rulers next to them, which would signify ratio data. Now, my A column does not. So I'm going to go really quick just because I want to fix this. I'm going to go back to my data set. I'm going to click on this A, and I'm going to make this scale. There we go. So it knows it's scale data. It really doesn't matter, to be quite honest, for this analysis. It'll treat it the same way, but that's fine. So let's go back to our correlation. And let me delete that real quick. Okay, so here's our correlation. I'm going to pick my variables, variable A, variable B. And already it's done the correlation for me. The R value is negative 0.753. I can click on report significance and it tells me the p-value is 0.001. I can flag significant values. Obviously that's quite significant. It did a Pearson correlation. Now you recall, if this was non-parametric data, we would do a Spearman's row, but we're considered this to be scale or ratio data, so we'll consider it parametric. We can even do a scatter plot if we'd like. We can make a nice little scatter plot down here, very similar to our graph we just saw. And so this is great, but there's still another part we can do here. We can do a regression. So I'm going to remove our plot here just because I don't need that right now. We're going to go to linear regression. Okay, so now it wants to know, okay, what's the dependent variable? Well, for this experiment, we're going to assume that A is our independent variable and B is our dependent variable, or more specifically, the variable we're trying to predict. And so dependent variable is going to be the variable we're trying to predict. And so B is that one, so we're going to make that the dependent variable. And you see already there's some math, some data tables going up on here. And we then are going to scroll down here. We're going to see where it says method. We're just going to put enter. There's different methods we can use, but we're just going to leave that as it is. Alrighty. Now as we look on the side here, it's going to give us some values, and I'm actually going to make my A value my covariate. Right, there we go. My A value is my covariate column. And so what it's now done, if you look off to the right here, it's given me a little more complicated information than Excel, but it's actually given me the same information. It has given me a ANOVA table, and I'm going to push this over. It's given me an ANOVA table for the regression line. It's significant at 0.001, which we knew already from the correlation. And then it gives me down here my coefficients. Now, I know we haven't gone terribly in depth here in the regression and these tables, and a lot of this is going to seem like numbers to you. But actually, it has given us the coordinates for the regression line. You may just not have picked up on it. If you'll notice here in our table, there's two numbers, 4.98 and negative 0.164. Okay, well, if we go back to our Excel document, remember those numbers, 4.98, negative 0.164. You'll notice that the coordinates for our regression equation, according to Excel, is y equals negative 0.1638 or negative 0.64 plus 4.98. So we actually have the two values that we can put in our regression equation. Now, does it give you this exact equation? No, it doesn't write it like that. But it does give you the slope, which is negative 0.1638, and it gives you the y-intercept, which is 4.98. So we can come up with that same equation using these coefficients from our table. Okay. There are other things we could do down here, which I'm not going to go through. We can do some plots if we wanted to. I have said before, I do think Excel is better as far as making our charts and tables, especially line graphs would be my argument, because you can make them a little bit prettier. You can organize them a little bit. You can organize that. You can put the regression equation in there if you so choose. There's other data here if we wanted to look at some other statistics, but this is a bit advanced for what we're going to do just for this assignment. So that's how you do a correlation and regression in JASP. I hope that helped, and we will see you in the next video.